Question number 46 is 2 grams of metal carbonate is neutralized completely by 100 ml of 0.1 normal HCl. The equivalent weight of the metal carbonate we need to find out. First of all, they have given us 100 ml of 0.1 normal HCl. So we'll calculate the number of gram equivalent of HCl. So that will be equals to 100 ml multiplied by 0.1, we'll divide this by 1000, that will get around 0.01. Now this has been neutralized with the metal carbonate, so number of gram equivalent of HCl and that of the metal carbonate will be same. So therefore the 1 gram equivalent of the metal carbonate is equals to, they have taken 2 grams, so 2 gram divided by 0.01, that will be equals to 200 gram. Therefore, option D. Question number 47. The law of constant composition is same as the law of conservation of mass, conservation of energy, multiple proportion and definite composition. The constant composition is the definite proportion. Therefore, option D. Question number 48. What does the electronic configuration 1s2, 2s2, 2p5, 3s1 indicates? Now over here it indicates generally the above rule if we follow, the 2p should be completely filled and then electron should go in 3s. But here it is 2p5 and 3s1, that indicates one of the electron has gone to the higher step. When I am talking about the configuration 1s2, 2s2, 2p6, this is of neon. So one of the electron from the 2p is excited to the 3s. Therefore it is excited state of neon. Question number 47. The uncertainty in the momentum of the electron is 1 into 10 raised to minus 5 kg meter per second. The uncertainty in its position we need to determine. So we have a formula delta x into delta p, that's equals to h upon 4 pi. Delta x is the uncertainty in the position. So momentum is given h is 6.63 into 10 raised to minus 34 divided by 4 into pi, it's 3.14 into delta p. Delta p is given 10 raised to minus 5. So that comes out to be 5.27 into 10 raised to minus 30 meter. Therefore option D. Question number 50. Which of the following element never shows positive oxidation state? So the element which is not showing the positive oxidation state is fluorine. The anion HCOO minus, the 2 carbon oxygen bonds are found to be equal in length. So if we'll talk about HC double bond O minus. Now these 2 CO bond have the equal length. The reason behind this particular structure shows the resonating nature. So electronic orbital of carbon atoms are hybridized. The C double bond O bond is weaker than the CO bond. The anion HCOO minus has 2 resonating structures. So therefore option C. Question number 53. If both the oxygen and helium are at the same temperature, the rate of diffusion of O2 is very close to. So according to the Gram's law, if we'll see, the rate of O2 upon rate of helium is equal to square root of molecular mass of the helium divided by molecular mass of the oxygen. That's equals to the square root of 4 upon 32. So this is nothing but R of O2 is equals to 0.35, that is R of helium. So we have such option C over here, that is 0.35 times of the helium. Therefore option C. Question number 54. Hess law is used to calculate. Generally Hess law is the enthalpy change during the process. Therefore option A. Question number 55. The quantity of heat measured in the reaction in the bomb calorimeter. The heat of combustion is generally measured using that bomb calorimeter, in which the delta E is calculated, that is into C into delta T into molecular weight upon mass. So in short, C is the heat capacity, delta T is the difference of the temperature, then M is the mass of the substance and M is the molar mass. Therefore option D. Question number 56. 100 ml of 0.015 molar HCl is mixed with 100 ml of 0.05 molar of HCl. What will be the pH of the solution? So before calculating the pH, we will calculate the resultant normality. That's equals to N1V1 plus N2V2 divided by V1 plus V2. So the first solution is given 0.015, that is of 100 ml, plus second solution 0.005 into 100 ml and divided by the total volume, that is 200 ml. So that is equals to 10 raised to minus 2. And if we calculate the pH is equals to minus log to the base 10 of H plus ion. So if we calculate the pH of 10 raised to minus 2, that will comes out to be around 2. So option C. Question number 57. The reaction Ag2 plus Ag giving twice of Ag plus. In this case, if you will find the Ag2 plus, the oxidation state has decreased, while with respect to Ag, it has increased. So in this case, the same element undergoing the oxidation and reduction both. Therefore, this is disproportionation reaction. The oxidation number of the chromium in the potassium dichromate is. Now, in case of potassium dichromate, that is K2Cr2O7, potassium is plus 1. There are two potassiums, so plus 2. Plus, let us assume X as for the chromium. There are 2 chromium, therefore twice of X. Plus oxygen minus 2 into 7, that is minus 14, that's equals to 0. So X is equals to plus 6. Therefore, option C. Question number 59. When hydrogen peroxide is added to the acidified potassium dichromate, the blue color is produced. Now, when I'm talking about the potassium dichromate, that is K2Cr2O7, when it is acidified, that means in presence of H plus, it is allowed to react with H2O2. The potassium dichromate itself changes to the CrO5, that is peroxide of the chromium, which is blue in color. Therefore, option C. Question number 60. The carbonate that will not decompose on heating, the carbonate which is not undergoing any kind of decomposition, it's Na2CO3. Question number 61. The correct order of increasing atomic radii. The smallest among them will be boron. While the aluminium and gallium, there is an exceptional. Gallium has the smaller atomic size compared to the aluminium. Therefore, option D. Question number 62. Which of the following is used in making the printing ink, shoe polish, black varnish and the pen? Lamp black, bone black, that is carbon black, and the none of the above. The answer is lamp black, which is used for all purposes. Carbon black is used for making the tires, while the bone black is used for the decolorization of the sugar. Which of the following is not likely to show the optical isomerism? To show the optical isomerism, there should be a symmetric carbon atom. In the first case, the two sides are same, so it is not a chiral carbon atom. Option B contains the chiral carbon atom, in which this carbon is attached to the 4 different atoms and group. Therefore, it can show the optical isomerism. Question number 64. The condition for the aromaticity is molecule must have the clouds of the delocalized pi electrons, and molecules must contain the 4n plus pi, that is Huckel's rule. Therefore, option A and B both. Option C. Question number 65. Organic alkadine on reduction with reductive ozonolysis produces the acetaldehyde, acetone and 2-methyl propane 1,3-diol. What is the formula of this? So let us first write what are the different products which we are getting. First is acetaldehyde, so CH3CH double bond O. Next I am writing the compound number 3, that is propane 1,3-diol, so C double bond OH, CH3 2-methyl, so CH double bond O, and the third compound we are getting, that is acetone, CH3CH3. Now wherever we have this oxygen bond, there will be a double bond. So that is the reductive ozonolysis that is taking place. If we combine CH3CH double bond CH3 CH double bond CH3CH3. So if you'll see, this kind of compound is present as option E. Question number 66. Addition of the phosphate fertilizers into water leads to increased growth of the decomposers, reduced algal growth, increased algal growth, and option D, eutrophication. This causes the eutrophication, that is the deposition of the phosphate layers. Question number 67. Which one of the following is a covalent crystal? Rock salt, ice, quartz, and the dry ice. The quartz, that is SiO2, which is showing the covalent bonds. Question number 68. Which element is used for making a transistor? Transistor can be made by using the silicon. Question number 69. Assuming that the seawater is 3.5 weight percentage aqueous solution of NaCl, what is the molality of this seawater? So when I'm talking about the 3.5% of NaCl solution, that is containing 3.5 grams of NaCl, and water will be 100 minus 3.5, that is equals to 96.5 grams of water will be present. So molality of the solution, that is weight of the substance, 3.5 divided by molecular weight of the NaCl is 58.5 multiplied by weight of the water in kg, that is 0.0965, that is equals to 0.62 molar. Therefore option C. Question number 70. How many grams of dibasic acid should be present in 100 ml of aqueous solution to make 0.1 normal solution? So it is dibasic and the molecular weight is given 200. Therefore equivalent weight is equals to the molecular weight divided by 2. Therefore 200 divided by 2, that is equals to 100. So now normality of the solution is the gram equivalent of the substance, that is weight of the substance divided by its equivalent weight multiplied by volume in liter. We need to make 0.1 normal of 100 ml. 100 ml means 0.1 liter. Equivalent weight is 100, that is we need to find the mass of the substance. Therefore we'll get the answer, that is 1 gram. Therefore option D. Question number 71. The cell reaction of the galvanic cell. In this case, the copper is acting like an anode, so oxidation will take place, and mercury is the cathode, therefore reduction will take place. So the overall reaction will be Cu will undergo oxidation to become Cu2 plus, while mercury Hg2 plus will become Hg. Therefore option D. Question number 72. For the gaseous reaction, the units of the rate of the reaction. For the gaseous reaction, we generally write it as atmosphere per second. Therefore, option B. In the reversible reaction, twice of NO2, K1 upon K2, N2O4, the rate of disappearance of the NO2 is equals to. Generally, we write the rate of the equation is in terms of NO2. So it is minus half, since it is reactant, negative sign, D of concentration of NO2 divided by dt. Also, this is equals to forward reaction K1 and concentration of NO2 square minus backward reaction K2 into concentration of N2O4. Therefore, minus D of NO2 by dt, that's equals to 2, I'm taking on that side. So 2K1 NO2 square minus twice of K2 into N2O4. Therefore option B. Question number 74. The pest is nothing but the suspension of solid in liquid. Therefore option A. Question number 75. The luster of the metal is due to its high polishing, high density, its chemical inertness, and the presence of free electron. The mobility of electron, that is free electrons, are responsible for the luster. Question number 76. The purest form of iron is? The purest form of iron is called as a wrought iron or malleable iron. Question number 77. In manufacture of sulfuric acid by the contact process, the Tyndall box is used. The dust is the colloid which shows the Tyndall effect. Hence, the Tyndall box is used to test the presence of the dust in the gaseous mixture while making so that the catalyst can be can perform effectively. Therefore, option D, test the presence of dust particles. Question number 78. The method chiefly used for the extraction of the lead and tin. Lead is generally undergoes the self-reduction process, while tin can be reduced by the carbon reduction. Therefore, option A. Question number 79. The metal gives the hydrogen gas on heating with a hot concentrated alkali, that's zinc. Zinc on treatment with the NaOH, that is gives the sodium zincate along with the liberation of hydrogen gas. Therefore, option C. Question number 80. Which of the following is not an isomer of the but-1 So if you look at this particular compound, option D is not the isomer because it is not having the similar molecular formula with but-1. Question number 81. One of the following that cannot undergo dehydrohalogenation. To undergo dehydrohalogenation, the compound must have the hydrogen and halogen. Therefore, option B, since it's not having the halogen. Question number 82. The phenol is reacting with the C2H5I. So this will give us formation of corresponding ethylated products. So C6H5OC2H5, option A. Question number 83. The dehydration of but-1-ol gives but-1-ol. So that is CH3, CH2, CH2, CH2OH. So when this will undergo, when it is dehydrated in presence of H+, the water is lost from here. So we'll get CH3, CH2, CH2, CH2. This is positive. The hydride is shifted to this carbon and positive charge will be shifted, tautomerism. So we'll get CH3, CH2, CH, positive CH3. This change take place because this is primary carbocation and this is secondary. Secondary is more stable. And finally this loses proton so as to get CH3, CH double bond, CH, CH3. Therefore, I am getting but-2 as a major product. Therefore, option B. Question number 84. Amide contains C double bond O group, yet they do not give the characteristic reactions of the C double bond O. The reason behind this, option A, they dimerize, option B, of the resonance, they possess the cyclic structure, and option D, they are attached with the alkyl group. So that's option B, because C double bond O undergoes the resonance. Question number 85. The Gabriel's synthesis is used frequently for the preparation of the following reaction. Gabriel's phthalimide synthesis is used for the preparation of the primary amine. Therefore, option A. Question number 86. Secondary nitroalkane can be converted into ketone. This is generally done in presence of the aqueous acidic medium. Therefore, option A. Question number 87. Which of one of the following is not a protein? Wool, nail, hair, and DNA. Option D, DNA. In natural rubber, isoprene units are linked to each other. They are attached in the form of head to tail manner. Therefore, option C. 89. Which of the following is the polymer of the three different monomer? Option A only, because it's a combination of as acrylonitrile. B stands for butadiene and S stands for styrene. Question number 90. Which set has a different class of the compounds? Tranquilizers, equanyl, heroin, Valium. Heroin is not a tranquilizer, it is the analgesic. Therefore, option A.